This is the last example for section 1.4. A 10-gram ice cube has a temperature of -5 degrees Celsius. How much heat is needed to melt the ice cube and warm the resulting water to room temperature, which is telling us is 20 degrees Celsius? So basically we have to break this problem into three parts. We need to first figure out how much heat was needed to increase the temperature from -5 degrees Celsius to 0 degrees Celsius. Then we need to know the heat that was needed to melt the ice. Finally, we need to know the heat that was needed to raise the temperature from 0 degrees Celsius to 20 degrees Celsius. I'll start with going from -5 degrees Celsius to 0 degrees Celsius, and we are going to use the equation Q is equal to the mass of the water, I guess ice in this case, times the specific heat of the ice, times the change in temperature. We're given that the mass of the ice is 10 grams. The specific heat, C, is equal to 0.49 calories per gram degrees Celsius. Finally, of course, the change in temperature is equal to the final temperature of 0 degrees Celsius minus the initial temperature of -5 degrees Celsius. So that is going to be a positive 5 degrees Celsius for change in temperature. Substituting these values into our equation, 10 grams for the mass times 0.49 calories per gram degrees Celsius for the specific heat times 5 degrees Celsius for the change in temperature. Cancel out the grams, cancel out the degrees Celsius, and we get 24.5 calories of heat. Then, to calculate the heat required to melt the ice, let's call this Q2, and the book calls the first part Q1. So Q2 is equal to the mass of the ice times the heat of fusion for the ice. The mass of the ice is, of course, still 10 grams. The heat of fusion is 79.8 calories per gram, which is found in the chart right above this example, and it is table 1.8. Simple multiplication problem, we substitute 10 grams for the mass times 79.8 calories per gram for the heat of fusion. Of course, grams cancel out, and we're left with 798 calories to melt the ice. Significantly more than raising the temperature by 5 degrees. Lastly, we need to calculate the heat required to raise the temperature from 0 degrees Celsius to 20 degrees Celsius. And we're going to use, again, heat is equal to mass times specific heat times change in temperature. Mass, once again, is equal to 10 grams. The specific heat for water we have used before, and you should remember that it's equal to 1.00 calories per gram degrees Celsius. Lastly, of course, the change in temperature is equal to the final temperature of 20 degrees Celsius minus the initial temperature of 0 degrees Celsius. So it is 20 degrees Celsius. Making the appropriate substitutions, we have that the mass is 10 grams, the specific heat is 1.00 calorie divided by gram degrees Celsius times the change in temperature of 20 degrees Celsius. Once again, the degrees Celsius and the grams cancel out, and we have 10 times 1 times 20, giving us a heat of 200 calories that is required to raise the temperature of 10 grams of water 20 degrees. Finally, to figure out the total heat that is needed, we add all of these together. We have 24.5 calories to go from negative 5 degrees Celsius to 0 degrees Celsius. We have 798 calories to melt the ice. And then we have 200 calories to go from 0 degrees Celsius to 20 degrees Celsius. Altogether, this gives a total of 1,022.5 calories required to change 10 grams of ice at a temperature of negative 5 degrees Celsius into liquid water at a temperature of 20 degrees Celsius.